All right, so power. Let's try to recall what power is. Power, if you remember, is the rate in which energy is either produced or consumed. This is the rate in which energy is produced and transformed, but consumption works differently too. So when we talk about power, we're talking about a joule per second, or what's known as a watt. So when you're looking at a light bulb, you're looking at the wattage of power, right? The amount of power, the amount of joules that it consumes per second. Okay? So from what we know, from what our definitions are, for the three main definitions that we have, how can we get power? Excuse me, how can we get power? Well, if you look at voltage, voltage is the it's a joule per coulomb. Okay? So it's the amount of energy that can be produced in coulomb of joules. Okay? That's voltage. And it's actually the change, but the unit still remains a joule per coulomb. Now, if I wanted to get energy out of there, I'd take my voltage and I would multiply it by charge. Okay? So that would give me energy. But that's not all that helpful, considering that when you look at a circuit, and you're looking at current flowing through a circuit, you're talking thousands, hundreds of thousands, millions of electrons that are individual charges that are moving through the circuit. Okay, they're all moving through the circuit. All of them have that much energy, this voltage times the charge. So looking at the energy of a circuit is not all that beneficial. It's more beneficial to talk about power. Now, if you talk about charge, you talk about voltage, and you say, well, I want power, charge, voltage times charge divided by the second. So that's no longer energy, that's power. Well, what is a charge per second? We call an amp. So this right here is an amp. So when you're looking at power, realize that it's voltage times current. Okay? That's power. So inside a circuit, the amount of power that's being produced by a particular voltage is equal to that numerical value of that voltage times the current that's being produced. That's the power of that circuit. Okay? And I like to think of VI as power production, not necessarily consumption, but definitely production. This is the amount of electrical power that's being produced by this voltage. Okay? Now, if I wanted to convert that, I wanted to talk about power in a resistor. More importantly, power consumed by a resistor. Then I'm going to get rid of this voltage. Okay? Now, using Ohm's law, this idea that V is equal to IR, I'm going to substitute IR in for V. And I end up with I squared R. So both of those are power. And both of those are equations for power. But I like to think of VI as production because it is talking about the voltage. And I like to think of this I squared, and let me make that a little darker there. This I squared R as power consumption. Excuse me. How much power is being consumed in a light bulb? So when you're looking at a 60-watt light bulb, that's the amount of power that's being consumed by that light bulb. In consumption, like I say, it's not really what's going on. It's transforming. It's transforming that electrical power into thermal, into light. Okay, so that power that's being produced here is being transformed through the resistor. For the sake of talking about only the circuit system, not about products of heat and that sort of stuff, that I like to think of it as consumption. Okay, so that's power in a